At the heart of an LLM lies three core components: data, architecture, and training. The data component involves feeding the model enormous quantities of data, text, probably, to learn from. And for the architecture, LLM typically uses a neural network, with the transformer architecture being a popular choice. This architecture empowers the model to comprehend sequence of data, such as sentences or lines of code, by considering the context of each word in relation to every other word. During training, the model learns to predict the next word in a sentence. Initially, it's making random guesses, but throughout iterative adjustment to its internal parameters, the model refines its prediction until it can reliably generate coherent sentences. This iterative process of prediction and adjustment gradually enhances the model's proficiency, enabling it to understand nuances like the difference between bug, yellow, sky, or bottle. Furthermore, fine-tuning allows the model to specialize in specific tasks by training on a smaller, more targeted dataset, thereby refining its understanding and enhancing task-specific performance.